Alright, for this video we will be graphing another rational function and doing a little bit of analysis. This one should be relatively simple because there's not much going on in the numerator, it's just the number 1. We might as well go ahead and factor the denominator so we can see everything. Excuse me. X squared is x times x. 3 is 3 times 1. Inner plus outer equals middle. Inner, I have 3x. Incorrect. Inner, I do have 3x. Outer, I have 1x. I'm trying to get a middle of -2. If this is negative and this is positive, that will give me -2. So there's my -3, and I need a positive 1, so there you go. Alright, so we factored it. Also, -3 times positive 1 is -3, so that's cool. Now, the vertical asymptotes do come from the denominator, the zeros of the denominator. So if I set these two equal to 0, x minus 3 equals 0, and x plus 1 equals 0, that's going to give me x equals 3, and subtracting 1 from both sides, x equals -1. So I will have two vertical asymptotes, one at 3 and one at -1. I'm going to draw them now. Alright, so there you go. Now for the horizontal asymptote, remember we need to stop and consider the degree. Which one of these three situations are we in? If the degree of the numerator is less, then y equals 0 is the horizontal asymptote. If the degree of the numerator and denominator are equal, then we divide the leading coefficients. If the degree of the numerator is greater, then there is no horizontal asymptote. Which situation are we in? Well, let's take a look here. See? The degree of the numerator is 0 because there are no x's up here. The degree of the denominator is 2 because of this. So the degree of the numerator is less, and that means the horizontal asymptote will be y equals 0, which will be a horizontal line. It's the x-axis. So I'm just going to go ahead and graph that right now, like so. Okay, and I think I will. Okay, so there's my horizontal asymptote. So now it's time to plot a bunch of points. So I'm just going to type this equation into my calculator and start plotting a bunch of points. So I've got 1 over x squared minus 2x minus 3. So I've got 1 over x squared minus 2x minus 3. Let's see, is that right? Yes. Now, in addition to all the points we need to plot, look, we need to plot some points to the left of this vertical asymptote. We need to plot a few points in between, and we need to plot a few points to the right of the vertical asymptote. Alright, so we need at least 9 points, 3 here, 3 here, and 3 here. But whatever else you do, let me mention the points that students typically forget to plot. I don't want all integers, I want some decimals. Specifically, I want the decimals that are very close to the vertical asymptote, just a little bit to the left and a little bit to the right. To get those decimals, I'm going to use ask mode for a moment. So I'm going to switch from auto to ask. Okay, now it's waiting for me to type in whatever I want. So just to the left of the vertical asymptote, this is at -1, so -1.5 would be a decimal to the left. So here I go, 1.5. All right, I see the y value. Going just a bit to the right of the vertical asymptote, just a bit to the right would be negative 0.5. So let's see, negative, and I'll say 0.5. And I see that value right there. Now, coming over to the other vertical asymptote is at 3. So just a decimal to the left would be 2.5. So I definitely want to do that, 2.5. Okay, I will also want a decimal to the right, but it only gives me space for 3 at a time. So let's see what's going on at negative 1.5. Now 4/9 is a 0.4, repeating. So 0.4, it's a little bit less than half. Okay, so at just to the left, I'm at positive just a little bit under a half. So it's going to be right there. Okay, what else you got? All right, at negative 0.5, I'm at negative 4/7, which is negative 0.6. Okay, so here I am at negative half, and it's going to be negative 0.6. So that's just a little bit more than half a unit down. Okay, so I've got that. At 2.5, I've got the same thing. Okay, so 2.5 would be right here, and it's going to be also negative 0.6. So about there. Okay, I also want to find out what's happening at 3.5, all right? Just a decimal to the right. Okay, so I'll go ahead and type that in, 3.5. Oh, and look, it's 4/9 again. Same as this. Okay, so I've got those 4 points. Now, I'd like a couple more points over here to the left, but for the rest of the points, I'm going to switch back into auto mode so I can just scroll without all this typing. I just needed ask mode for the decimals. Okay, so let's see. Let's go ahead and take a look at -2 and -3. So at -3, I'm at -1/12. Which is really small, and at -2, I'm at 1/5. So I got 1/12 and 1/5. So both of those are really, really close to the asymptote, which is what you would expect. As we go to the left, we should be approaching the asymptote. So it does make sense. Okay, so basically, I'm at you're practically on the asymptote by the time you get over here. So it is approaching. So that's enough information to tell me that this branch over here on the left, it's got to approach both asymptotes, so it's going to be tough for me to draw, but I'm going to do my best. It's going to appear to be tracing the asymptote because it's so close. Okay? But just in your mind, know that it's not really touching the asymptote. And then you see it's going up here, and it's going to have to go ahead on up and approach the other asymptote. So it's going to do like this, and again, it's going to appear to trace the asymptote by the time it gets to the end. So that's what's happening there. Now in the middle, I need at least one more point here in the middle, because I want at least 3. Let's see what's happening at 0 and 1 and 2. And so we can just scroll through. So at 0, we're at -1/3 of a unit. Okay, so that's going to be like right there. Okay, what about at 1? Okay, I'm at -1/4, which is a little closer to 0, and then back to -1/3 again. Okay, so I'm really close. So you can see it's just making a small little arc right here with these values. So that's enough to show me how to draw it. All right, it's getting a little bit lower and then getting closer and then a little bit lower again. So let's go ahead and draw that. So of course it's got to eventually approach the asymptote, and by the time it gets to the asymptote, it's so close that it's appearing to trace it, but in your mind just understand that it's not really touching, it just looks that way. Okay, so that's going to look very much like that. And it disappeared, so that's lovely. Okay, and let's see what's going on over here. But you can bet that it's going to approach the asymptote over here as well. But let's go ahead and look at 4 and 5. All right, and 4 is 1/5, and 5 is 1/12. So 1/12 is so close to 0 that it's going to already appear to be touching the line. Okay, so you know, 1/4 and 1/12. So you can see what's happening. It is in fact approaching the asymptote, and it's going to appear to trace it. And you can bet that it's going to, okay, it disappeared. That is frustrating. And you can bet that on this side it's going to also approach the asymptote. Okay, so this is what your graph should look like. All right, let's go ahead and talk about the domain. Now, this graph goes left forever and right forever, but there are 2 vertical asymptotes which must be skipped. So when you do your domain, look at your vertical asymptotes. So remember, I have a vertical asymptote at -1 and 3. So my domain is going to go from -infinity to -1. But then there's an asymptote there, so I have to stop and say union. And then this part in the middle goes from -1 to 3, union, and then this part on the right picks up and goes from 3 to infinity. Okay, and we're using parentheses instead of brackets to show that the asymptote is not included. The graph is skipping over -1, so it's not touching -1 or 3. And that's it. So that is it for problem number 4. That's all we were asked to do.